The Bundesstraße 16 B16 is a vital road artery connecting Neuburg an der Donau and Donauwörth in Germany. Over the years, this stretch of road had seen wear and tear due to increased traffic and higher axle loads, causing the surface to deteriorate significantly. To address this issue and provide a more robust road infrastructure, an ambitious project was undertaken to reconstruct a 3.5-kilometer section of the B16. This project aimed not only to repair the road but to revolutionize the way roads are built, utilizing a cutting-edge compact asphalt construction method. In this article, we'll delve into the details of this groundbreaking pilot project that has the potential to reshape the future of road construction. The typical wear and tear of conventional asphalt construction methods had become evident on the B16 stretch between Neuburg an der Donau and Donauwörth. As traffic increased, the asphalt surface had deteriorated, with seams separating and deep cracks appearing in some areas. This deterioration was a clear sign that a comprehensive renovation was long overdue. The solution to this road renovation challenge was the introduction of the innovative compact asphalt construction method. Designed to produce a high-quality, two-layer road surface in record time, the project involved the creation of an 8-centimeter thick AC 32 TS asphalt base layer and a 2-centimeter thick SMA 8S split mastic asphalt top layer, totaling 1,600 tons and 1,320 tons, respectively. Initial preparations. The project kicked off 4 days before the actual construction began. During this phase, a powerful 1,000 horsepower cold milling machine was employed to remove the existing road surface, reducing it to a 9-centimeter residual height. This impressive machine effortlessly cut through the old asphalt layers. Material transport. The milled asphalt was loaded directly into waiting trucks with remarkable efficiency. Despite a milling depth of 13 centimeters, the loading process took less than 3 minutes per truck. Logistics. The project required a highly efficient logistics chain to transport the milled asphalt to nearby mixing plants in Genderkingen, Ebenhausen, and Augsburg. After a 21-kilometer journey, the milling material reached the Genderkingen mixing plant. Asphalt recycling. At the mixing plant in Genderkingen, the reclaimed asphalt was processed to uniform grain size, dry stored, and combined with bitumen to create a highly load-bearing asphalt mixture. Granulate processing. Asphalt granulate processing involved a chain-driven horizontal impact crusher, reducing the material to the desired grain size. Depending on the material size, up to 250 tons of asphalt could be processed within an hour. Storage. The processed asphalt granulate was stored in large warehouses, capable of holding up to 12,000 tons of coarse asphalt granulate. Dry storage was crucial to prevent rainwater ingress, minimizing the need for extensive drying processes. The asphalt production occurred simultaneously across 3 plants, Genderkingen, Bar Ebenhausen, and Augsburg. These plants collectively produced 430 tons of asphalt per hour. Material transport. Specially equipped trucks with temperature-maintaining thermocovers transported the freshly produced asphalt mix to the construction site. Construction process. The B16 section was completely closed to traffic for the construction phase. The compact asphalt construction process involved a specialized machine called the Dynapack F300. Various precision instruments for distance measurement, layer thickness, surface temperature, and evenness were attached to the machine. The key innovation in this project was the simultaneous application of the base and top layers in a hot-on-hot method. This allowed for twice the speed of construction, 100% compaction, superior bonding between layers, and a more durable road surface. Continuous monitoring of temperature and compaction ensured the highest construction quality. Ultrasonic sensors provided real-time data on surface evenness. To protect the road from moisture, the edges were thoroughly sealed, and a bitumen-based primer was applied to ensure a lasting bond between the new and existing asphalt layers. The construction was rounded off with road markings. The reconstruction of the B16 section between Neuburg an der Donau and Donauwörth stands as a testament to innovation in road construction. Thanks to the cutting-edge compact asphalt construction method, this 3.5-kilometer stretch was rejuvenated in record time while offering numerous benefits. The hot-on-hot application method not only expedited construction, but also improved road quality, durability, and safety, with its potential to reduce traffic disruption and lower long-term maintenance costs. This pilot project has paved the way for the future of road infrastructure in Germany. The B16 project demonstrates that by embracing innovative technologies and methods, we can create safer, more efficient, and longer-lasting road networks for the benefit of all road users.
The process begins with ripping the existing ground or subgrade. This step involves using heavy machinery, bulldozers or rippers, to loosen the soil and create a rough, fragmented surface. The purpose of ripping is to break down compacted layers and prepare the area for the subsequent injection of slurry. This step ensures that the slurry penetrates effectively into the ground, achieving better stabilization. Once the ground is adequately ripped, a specially formulated slurry mixture is injected into the soil. The slurry typically contains a blend of stabilizing agents, such as lime, cement, or other binding materials, mixed with water. This mixture is applied uniformly across the surface using specialized machinery. The injection process enhances the soil's properties, improving its strength, stability, and resistance to moisture. After the slurry is injected, the next step is to mix the soil and slurry thoroughly. This is done using rotary mixers or other specialized equipment designed to blend the components evenly. Proper mixing ensures that the stabilizing agents in the slurry are evenly distributed throughout the soil, eliminating weak spots and creating a homogeneous base layer. Once the soil and slurry are mixed, the material is compacted using pad foot rollers. These rollers are equipped with raised pads that apply high pressure to the ground, forcing out air pockets and increasing the density of the mixture. This step not only strengthens the stabilized layer, but also ensures that it meets the required engineering specifications for load-bearing capacity. Proper compaction minimizes the risk of future settling or deformation of the road. After compacting, the surface is shaped and leveled using motor graders in a process known as finish blading. This step ensures that the road base has the desired profile and grade, providing a smooth foundation for subsequent layers. Flat rolling follows, where a smooth drum roller is used to achieve a uniform flat surface. To ensure the quality and reliability of the stabilized base, density testing is performed. This involves measuring the compacted material's density using methods like nuclear density gauges or sand cone tests. The results are compared to the specified standards to verify that the compaction meets the required criteria. Micro-cracking is an intentional process that involves creating fine, controlled cracks in the stabilized layer. These cracks allow for slight movement and expansion of the material, reducing the risk of large-scale cracking over time. Specialized rollers or techniques are used to achieve this effect, ensuring the road base remains durable under varying weather conditions and traffic loads. The final step in the road construction process is paving the asphalt layer. Asphalt is applied over the stabilized base in multiple layers, typically consisting of a binder course and a surface course. Paving machines spread and level the asphalt, which is then compacted using smooth drum rollers to achieve a dense, smooth, and durable surface. This layer provides the necessary traction, wear resistance, and aesthetic appeal for the finished road. Rural India is home to approximately 69% of the country's population, representing 833 million people, with rural infrastructure, especially roads, being pivotal to transforming livelihoods by improving productivity, living standards, and reducing poverty. The demand for robust, eco-friendly, and cost-effective road construction techniques has grown significantly. Among the innovative solutions is the use of Coir geotextiles, a technology that blends ecological sustainability with practical functionality. India's vast geographical diversity poses significant challenges to rural road construction. The terrain includes mountains, forests, wetlands, deserts, and scattered habitations in remote areas. These geographical variations necessitate a diverse approach to construction, especially given the wide range of subgrade soil types, traffic patterns, and availability of construction materials. Conventional construction methods often lead to higher costs and environmental concerns, necessitating innovative, cost-effective, and site-specific technologies. Coir geotextiles, made from the husk of coconut fruit, have emerged as a promising alternative to traditional methods. India, particularly Kerala, contributes 66% of the global Coir fiber production, offering an abundant, locally available raw material. Coir geotextiles stand out for their ecological compatibility, durability, and cost-effectiveness. The subgrade is prepared with optimal moisture and compacted to achieve 100% compaction using methods like sand replacement or core cutter. This ensures a stable foundation for subsequent layers. Rolls of Coir geotextiles are laid over the prepared subgrade, ensuring proper overlap and secure attachment with clamps or ties. Attention is paid to eliminate folds or wrinkles, especially at curves and slopes. Aggregates are evenly spread and compacted over the core layer to form the subbase. This involves spreading and compacting graded materials, followed by the application of screening material to fill pores. Bitumen emulsion is applied as a prime and tack coat, followed by a 20 mm thick pre-mixed carpet. The final seal goad ensures durability and smoothness. Advantages of Coir geotextiles: separation and reinforcement. Coir geotextiles act as a physical barrier, preventing the migration of fines from the subgrade into the aggregate layer, thus preserving structural integrity. Drainage. Their inherent porosity ensures adequate drainage, allowing water to pass through while retaining soil particles. Eco-friendliness. Unlike synthetic materials, Coir geotextiles are biodegradable, leaving no long-term environmental footprint. Use of Coir geotextiles in the construction of rural roads. Introduction. Coir fibers are strong, biodegradable, and have a lifespan of over 5 years, making them ideal for reinforcing roads. Unlike artificial geotextiles that suffer degradation under UV rays, Coir geotextiles are resilient, providing excellent separation, drainage, and reinforcement functions. The use of Coir supports local industries, provides employment, especially for women, and promotes sustainable agriculture by boosting coconut farming. This renewable resource enhances livelihoods while contributing to eco-friendly development. By reducing the need for expensive construction materials and minimizing maintenance costs, this technology proves economically viable. Success stories. Several roads constructed using Coir geotextiles have demonstrated the effectiveness of this technology. The road between Wazika and Perambula in Kozhikode district. The Kakundu-Shavalpara road in the same district. The Karatamuku-Vanathi-Poil road showcases the durability and functionality of Coir geotextiles in real-world conditions. The Gameco GT3600 concrete curb and gutter slipform machine, equipped with advanced G+ controls and 3D guidance technology, was showcased in a recent parking lot project in Murfreesboro, Tennessee. England Contracting tackled 15,000 feet of curb and gutter work, including 43 islands with radii ranging from 2.5 to 4 feet. Leveraging a Topcon millimeter GPS system for stringless paving, they significantly boosted efficiency. Traditionally, such projects require substantial time for staking and string line setup. However, the GT3600 eliminated these steps, enabling the crew to complete 16 islands in a single day, a task that would have previously taken 2.5 days. Owner-operator Scott England noted that the Stringless system not only streamlined operations, but also reduced overtime, with no need to manage stakes and string lines. The GT3600 features an auger delivery system, preferred for its cleanliness and ability to handle larger volumes of concrete through tight radii. The machine's all-track steering and G+ system facilitate precision in navigating curves, ensuring smooth and consistent paving even in challenging layouts. The integrated GPS and millimeter GPS technology provide 2 to 3 millimeter vertical accuracy, crucial for concrete paving projects. England praised the user-friendly design of the Topcon system, emphasizing its superior accuracy over traditional string lines, particularly in achieving precise arcs. With the dirt, asphalt, and paving contractors working off the same digital model, the project benefited from seamless coordination. Scott England expressed enthusiasm for the GT3600, highlighting its transformative impact on productivity and enjoyment in slip-form paving. This project exemplifies how advanced technology and innovative machinery can redefine industry standards, offering enhanced accuracy and efficiency. Joint sealing and waterproofing technology plays a crucial role in ensuring the durability and integrity of concrete and asphalt surfaces. These technologies address the challenges posed by cracks, joints, and other vulnerabilities in construction materials, which, if left untreated, can lead to significant structural and environmental damage. Modern sealing technology is supported by advanced, construction-ready machines and equipment designed for the efficient processing and sealing of concrete and asphalt. These machines cater to the full range of asphalt sealing needs and selected areas of concrete sealing, offering comprehensive solutions for diverse construction and repair projects. The equipment is engineered with a focus on practical use in construction environments, ensuring that contractors and technicians can operate them with ease and efficiency. Whether sealing cracks in a roadway, joints in a parking lot, or preventing water infiltration in a building foundation, these machines provide a reliable and precise application. Professional repair of cracks and joints is essential, not only for the structural longevity of surfaces, but also for safety and environmental protection. Properly sealed joints and cracks help prevent water penetration, reduce freeze-thaw damage, and protect against the ingress of harmful chemicals or debris. This, in turn, minimizes maintenance costs and extends the lifespan of concrete and asphalt structures. The process begins with thoroughly cleaning the surface using a broom to ensure proper adhesion between the substrate and plastiroot roll grip. Removing dirt, dust, and debris is crucial for a seamless application. Is a two-component cold plastic material infused with anti-skid aggregates that provide high friction. These properties make it particularly suitable for areas requiring enhanced slip resistance, such as parking spaces or pedestrian zones. Add the provided accelerator pack, which is pre-measured for the material in the bucket, and stir it evenly into the mixture. Once ready, pour the cold plastic directly onto the prepared surface and use a paint roller to spread it evenly. This method allows for a uniform application, ensuring the coating adheres firmly to the surface. The tape used for edge markings should be removed while the cold plastic is still wet to achieve crisp boundaries. For areas requiring multiple colors, the process is repeated with a different shade of plastiroot roll grip, following the same mixing, pouring, and spreading steps. After the plastiroot roll grip application, preformed thermoplastic road markings are applied to add lines, symbols, or specific designs. These rolls are highly adaptable and can be cut to fit custom shapes or symbols. Position the pre-mark rolls on the dried plastiroot roll grip layer. Heat the pre-mark lines gently with a suitable heating device. Care must be taken to avoid discoloration or damage to the underlying cold plastic layer. Once the material is properly heated, it bonds firmly to the surface, ensuring durability and high visibility. Pre-mark rolls are particularly useful for creating special road marking designs, symbols, or lines to designate parking bays or traffic flow directions. This combination of materials ensures both functionality and aesthetic appeal, enhancing the overall look and utility of the marked space. Both materials are designed to withstand high traffic and environmental stress, ensuring a long-lasting finish. The anti-skid properties of Plastiroot roll grip enhance safety by providing high friction, reducing the risk of slips and skids. The flexibility of pre-mark rolls allows for the easy creation of customized symbols, logos, or markings, meeting diverse needs. Ease of application. The straightforward process ensures quick and efficient application with minimal disruption.
Manholes are a crucial part of our urban infrastructure, providing access to underground utility systems such as sewage, water, and telecommunication lines. Over time, these manholes can deteriorate, requiring repairs and maintenance. Traditional methods of manhole repair are often slow, labor-intensive, and pose significant safety risks to the workers involved. In 2002, a revolutionary solution was introduced, the Mr. Manhole system. This state-of-the-art set of tools and repair method has transformed the way manhole repairs are carried out worldwide. The Mr. Manhole system is designed to streamline the manhole repair process, making it faster, smarter, and safer for maintenance crews. Let's take a closer look at the full process of how it works. Assessment. The first step in the Mr. Manhole process involves assessing the condition of the manhole. Crews inspect the frame and chimney section to determine the extent of damage and the necessary repairs. Preparation. Once the assessment is complete, the crew prepares the work area. This involves ensuring the safety of the surrounding environment and setting up the necessary equipment. Frame removal. Traditional methods of manhole repair often require heavy machinery and manual labor to remove the manhole frame. With the Mr. Manhole system, this step becomes remarkably efficient. Specially designed tools are used to remove the frame quickly and safely, eliminating the need for heavy equipment and reducing the risk of worker injuries. Finishing touches. Once the frame is in place, any necessary finishing touches are made to ensure the manhole is restored to its original condition. This may include adjustments to the frame, leveling, and sealing to prevent future damage. Quality assurance. The Mr. Manhole system emphasizes the importance of quality assurance. After the repair is complete, a thorough inspection is conducted to ensure that the manhole is in optimal condition and meets all safety standards. The Mr. Manhole system has revolutionized manhole repair by making it more efficient, cost-effective, and, most importantly, safer for workers. With its specialized tools and precise techniques, manhole repairs can be completed in less time, minimizing disruptions to traffic and local communities. Hundreds of cities and municipalities across the world have adopted this innovative approach, recognizing its benefits for both their infrastructure and the well-being of their workforce. Cleanup. The final step involves cleaning up the work area and removing any debris. This ensures that the repaired manhole is safe for both maintenance crews and the public. The urban landscape of Zurich, Switzerland, has witnessed a significant transformation over the years. One notable aspect of this transformation is the meticulous process of tram track dismantling, a task undertaken with precision and expertise by Eberhard, a renowned name in the field. The journey of tram track dismantling begins with a comprehensive preliminary assessment of the existing infrastructure. Eberhard's team conducts a thorough inspection to evaluate the condition of the tram tracks, their age, and the materials used. This stage is crucial in determining the scope of work and the resources required for the project. The team also examines the surrounding environment to ensure minimal disruption to the city's daily life during the dismantling process. Once the initial assessment is complete, Eberhard engages in meticulous planning. This involves developing a detailed project plan that outlines the sequence of activities, timelines, and budget estimates. Obtaining the necessary permits and approvals from local authorities is another critical aspect of this stage. Zurich's strict regulations demand a seamless coordination between Eberhard's team and municipal authorities to ensure compliance with safety and environmental standards. Zurich is a bustling city, and tram tracks are a vital part of its transportation system. To minimize disruptions and inconvenience to residents and commuters, Eberhard employs a comprehensive traffic management plan. Temporary alternative routes are established, and signage is strategically placed to guide traffic. These measures are essential in maintaining the flow of public transportation and vehicular traffic during the dismantling process. The physical dismantling of tram tracks begins with the removal of surface layers. Eberhard's team employs specialized equipment and skilled labor to carefully extract the top layers of the tracks. This phase requires precision to prevent damage to the underlying infrastructure and to ensure a smooth transition for future projects. The heart of the project involves the dismantling of the tram tracks themselves. Eberhard's team utilizes heavy machinery and expert labor to lift and remove the tracks section by section. Care is taken to preserve salvageable materials for recycling, in line with Zurich's commitment to sustainability. The tracks are carefully inspected for any structural issues and replaced if necessary. With the tracks removed, attention turns to the underlying infrastructure. Eberhard assesses the condition of the roadbed, ensuring it is stable and capable of supporting future transportation needs. Repairs and upgrades are carried out as needed to enhance the durability and longevity of the newly laid foundation. In cases where the tram tracks are being upgraded or replaced, the installation of new tracks follows. Eberhard ensures that the installation adheres to modern standards, including safety features and noise reduction measures. The new tracks are integrated seamlessly into the urban landscape, maintaining Zurich's commitment to an efficient and environmentally friendly public transportation system. Before completing the project, Eberhard conducts a rigorous final inspection. Every detail is scrutinized to ensure that the tram tracks meet the highest quality and safety standards. This stage includes testing the tracks for proper alignment, electrical connections, and other essential elements to ensure the smooth operation of trams. Reinstating traffic and public services. Once Eberhard is satisfied with the quality and safety of the tram tracks, the final stage involves reinstating normal traffic and public services. The temporary traffic management measures are removed, and the city's tram system resumes its regular operations. Residents and commuters can once again enjoy the convenience of efficient and reliable public transportation. The town of Erbendorf, nestled in the heart of Bavaria, Germany, is known for its picturesque landscapes and charming streets. On September 1, 2012, the community witnessed a significant transformation as the long-awaited paving of State Road 2181, the town's central thoroughfare, commenced. This project marked a momentous event for the town, promising improved infrastructure, enhanced safety, and a boost to the overall quality of life for its residents. The decision to pave State Road 2181 had been a topic of discussion for several years. The road had been in a state of disrepair, causing inconvenience and safety concerns for both residents and commuters passing through Erbendorf. Potholes, cracks, and uneven surfaces had become a common sight, leading to increased maintenance costs and vehicle wear and tear. Moreover, the poor road conditions posed risks to pedestrians and cyclists, particularly during adverse weather conditions. Recognizing the urgency of the situation, local authorities collaborated with state agencies to secure funding and support for the road's rehabilitation. The paving project was a culmination of diligent planning, community involvement, and perseverance, It aimed not only to address the immediate road surface issues, but also to modernize the road infrastructure and enhance the town's connectivity. On that fateful day in September 2012, Erbendorf woke up to the hum of construction equipment and the smell of freshly laid asphalt. The paving process was a complex operation that required meticulous planning and execution. It involved several stages, including road preparation, grading, and the final asphalt application. The first step in the process was the removal of the old road surface. Construction crews worked tirelessly to excavate the existing pavement, exposing the road's foundation. This phase was crucial to ensuring a stable base for the new asphalt. It was a dusty and noisy endeavor, but the promise of a smooth and safe road ahead kept the town's residents hopeful. Once the old surface was cleared, the roadbed was meticulously graded and leveled. This ensured proper drainage and an even foundation for the upcoming layers of asphalt. The grading process was essential to prevent water accumulation, which had been a significant issue in the past. With the roadbed prepared, the next phase involved the laying of asphalt. State-of-the-art machinery was brought in for this task, making the process more efficient and precise. The fresh asphalt was carefully spread and compacted to create a uniform surface. This phase marked the most visually satisfying part of the project, as the road transformed from its rough and deteriorated state into a smooth black ribbon that stretched through the heart of Erbendorf. As the project neared completion, residents eagerly watched the progress, anticipating the benefits the newly paved road would bring. The improved road surface promised smoother rides, reduced vehicle maintenance costs, and enhanced safety for all road users. Additionally, the project aimed to promote economic growth by making Erbendorf more accessible, attracting businesses, and boosting tourism. The paving of State Road 2181 also reflected the town's commitment to sustainability. Modern construction techniques incorporated environmentally friendly materials and practices, aligning with the town's goal of reducing its ecological footprint. Proper drainage systems and the use of recycled materials were among the sustainable features integrated into the project. By the end of the day, on September 1, 2012, the town of Erbendorf had been transformed. State Road 2181, once a source of frustration and concern, had become a symbol of progress and community development. The successful completion of the paving project marked a significant milestone in the town's history, showcasing what could be achieved through determination, collaboration, and a shared vision for a better future. In the years that followed, Erbendorf continued to enjoy the benefits of the improved infrastructure. The smooth and well-maintained road not only facilitated daily commuting, but also became a source of pride for the town's residents. It served as a testament to what a community could achieve when it came together to address its needs and aspirations.